Welcome to lesson 6.2. We're going to be talking about polynomials and their linear factors. So these will be eventually used to graph and to solve and all that. So this is a little, basically like a stepping block to get us to some of the places that we're going to go later in the chapter. The objective here, two parts: analyze the factored form of a polynomial, and then write a polynomial from its zeros. So basically forwards and backwards. Just as you can rewrite a whole number as a product of its prime factors, you can write a polynomial as a product of its linear factors. So here we're being asked to take a polynomial and write it in standard form. So basically that means to multiply it out. So if you have three binomials, what I'm going to do is multiply two of them together first. Doesn't matter which two you pick, I'm just picking those two. So x times x is x squared, x times 4 is 4x, 3 times x is 3x, 3 times 4 is 12. So you end up with x squared plus 7x plus 12. Still haven't done anything with this x minus 1, so we're going to do that. X times everything in there is what I'm going to do first. So x times x squared is x cubed. X times 7x is 7x squared. X times 12 is 12x. Now I'm going to do negative 1 times everything in there. Negative 1 times x squared is negative x squared. Negative 1 times 7x is negative 7x. Negative 1 times 12 is negative 12. Add down, you get x cubed plus 6x squared plus 5x minus 12. So this is the polynomial that those factors came from. One thing I want you to notice, there's 3 x's there. You end up with a third degree, not a coincidence. I'm going to leave this one as potentially part of your exit ticket, but try it now. And you can pause the video and then come back to when I pick up again. But that will be part of your exit ticket. Example 2, we're going the opposite direction. So here's the polynomial, write it in factored form. It says you can sometimes use the GCF of the terms to help you factor, meaning look for the GCF first, if there is one. Between 3x cubed, 18x squared, and 24x, the GCF is 3x. So we're going to divide that out first, and you get x squared minus 6x plus 8. And then can you factor that? In this case, we can. The 3x is going to stay out there. We're looking for a pair of numbers that multiplies to 8 and adds a negative 6. So it'd be x minus 2 and x minus 4. All right, so those are the three factors of that original polynomial. Over here for x to the fourth, 3x cubed, and 4x squared, the GCF is x squared. All right, when I divide out x to the fourth divided by x squared, you get x squared. 3x cubed divided by x squared is 3x. 4x squared divided by x squared is minus 4. What multiplies the negative 4 and adds to 3? So it would be x plus 4 and x minus 1. Here, you have 5x would be the GCF. And 5x cubed divided by 5x would be x squared. 45x divided by 5x would be minus 9. X squared minus 9 is a difference of squares, so you have x plus 3 and x minus 3. 1/2 x cubed minus 1/8 x looks like it does not have a GCF, at least for the coefficients, but it actually kind of does. It's going to be 1/8 and then x. If I do 1/2 divided by 1/8, you get 4. And then x cubed divided by x is x squared. And 1/8 x divided by 1/8 x is 1. All right, and then the 1/8 x will stay out there. This is a difference of squares again. So you have 2x plus 1 and 2x minus 1. A little vocab for you. The relative maximum and minimum is the greatest or least value in a region of a graph. So the relative maximum of this is a cubic function, by the way. Relative maximum is here because it's the highest point in a region, but it's not the highest point overall. It does go up forever, but in this area, it's the relative maximum. The relative minimum is just the same, just down here. So in a region of the graph, it is the lowest point, but it's not the lowest point of the entire graph. If the polynomial is in factored form, you can use the zero product property to find the values that will make the polynomial equal to 0. So if it's already in factored form, you just take each factor, set it equal to 0. So your three zeros of the function are -1, 1, and -3. If you plot them, -3 is there, -1 is there, 1 is there, and you graph it on a graphing calculator, those are the zeros, but the curve is just going through all three. Okay. You don't need to write out those equations if you don't need to. So it's just whatever the opposite is, right? If there is no coefficient. So it'd be 7, 5, and 3 for that one, for part B. If they have coefficients, I suggest writing it out. So 2x minus 3 equals 0. Add 3, you get 2x is equal to 3. Divide by 2, you get x is equal to 3 halves. Okay, this one's going to be x equals 4. And then this one, 3x plus 1 equal to 0. Subtract 1, you get 3x is equal to -1. Divide by 3, you're going to get x is equal to -1/3. All right, I'm going to leave part D for you to try as an exit ticket. The factor theorem. Now we're going to be working in reverse. We have the zeros. What is the polynomial in standard form? So basically the exact opposite of what we just did in example 3. The expression x minus a is a linear factor of a polynomial if and only if the value of a is a 0 of the related polynomial function. So now I have the zeros. What this theorem is telling me is x minus a, or x minus each of these zeros, are the factors that the zeros came from. So if -4 is a 0, x minus -4 is a factor that it came from. So minus and negative would just make it plus. -2, same thing, x minus -2. So that means x plus 2 is a factor it came from. If it's positive, it's minus, right? So it'd be x minus 1. So these are the factors that these zeros came from. If I need it in standard form, that means multiply it together. If this word was factored, then you could leave it like this. If it says standard, that means multiply it together. So we're going to multiply it together just like we did in the first example. I'm just going to pick two of them and multiply them together first. Doesn't matter which two, I'm picking those two. X times x is x squared. X times 1 is -x. 2 times x is 2x. 2 times -1 is -2. So now I have x squared plus x minus 2. I'm going to multiply it by that x plus 4. X times x squared is x cubed. X times x is x squared. X times -2 is -2x. 4 times x squared is 4x squared. 4 times x is plus 4x. 4 times -2 is -8. And you have x cubed plus 5x squared plus 2x minus 8. Okay. Something that has an x of 0. Well, what is x minus 0? It's just x. X minus 2. X minus -3 would be x plus 3. We're going to multiply those together. What I would suggest definitely is do the two binomials first, and then we'll just multiply the x in after. So x times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, and then negative 2 times 3 is negative 6. So you end up with x squared plus x minus 6, and then x goes into there, x cubed plus x squared minus 6x, and that would be your polynomial answer for those zeros. Yeah. I'll leave these two for you to try on your own. I'll help you set them up. This is really no different. You just have two that are the same. So it would be x minus 2 and x minus 2. And then the minus 1 would make it x plus 1. So multiply those together. You can try that on your own. And then where it says plus or minus 3 and plus or minus 4, one value is 3, one value is negative 3. One value is 4, one value is negative 4. Just giving you that as a heads up, but just make the factors and then multiply them together. So give that a try. All right, a couple of vocabs here. A multiple zero is a repeated zero. So if you go back a slide, where you have the example that hopefully you tried on your own, where you have 2 and 2, like 2's there twice, right? That would be considered a multiple zero because it's there more than once. And then the multiplicity of that zero would be the number of times the zero occurs. So here, let's do example. We'll do example 5, and then state the multiplicity for each zero that we get. So we're going to factor like we did in example 2, and we're looking for a GCF first. So between x cubed, 4x squared, and 4x, you have x. You have x squared minus 4x plus 4. Then we factor, right? We're looking for what multiplies to 4 and adds a negative 4, so it'd be x minus 2 and x minus 2. So then your zeros are x equals 0. This one would be x equals 2, and this one would also be x equals 2. So you wouldn't say your answers are 0, 2, and 2. You would say your answers are x equals 0 and x equals 2 with a multiplicity of 2, meaning the 2 counts twice. So for this one, GCF is x cubed. You end up with x squared minus 6x plus 9. When you factor here, you're looking for what multiplies to 9 and adds a negative 6. So it's x minus 3 and x minus 3. So when x cubed is equal to, if you set x cubed equal to 0, and you take a cube root of both sides, you get x equals 0. So it's just 0. And then here you get x equals 3, and here you also get x equals 3. So you wouldn't say that your answer is 0, 0, 0, 3, and 3. You would say it's x equals 0, multiplicity of 3, and x equals 3, multiplicity of 2. Again, the multiplicity is how many times your answer counts. All right, I'm going to leave these last two as part of the exit ticket. All right, so some equivalent statements about there we go. Equivalent statements about polynomials. So for this function, -4 is a solution, but -4 is also an x-intercept of the graph, and -4 is also a 0 of the graph. And that means x plus 4. If -4 is a 0, then x plus 4 is a factor. So all of those things are connected. All right, I want you to try the exit ticket, and we'll go over all this tomorrow.